1.6 number 52. We're given two functions. F of x is 2 over the absolute value of x, and g of x is equal to x minus 1. We're asked to determine the domains of each of our functions and of the composition function, and then to graph them and see if we got it right. Okay. So the domain of our f of x is going to be determined by being away from these problem points that I've been talking about. And the problem points are even roots of negative numbers or dividing by 0. Okay, we don't have any roots in this problem, so we don't have that to deal with. But we do have this absolute value of x that sits here on the bottom. Okay, so we have to consider the problem points whenever this absolute value of x is equal to 0. Now, the absolute value function is this thing that says slope of -1 less than 0, +1 greater than 0, and modulo my ability to draw. It should be 0 only at 0. Okay? So we only have this problem point at x equals 0. So x not equals 0 is going to be the determining thing in our domain. Or in terms of our set notation, it's going to be -infinity to 0 with a curvy brace, and then 0 to infinity, right? We've plucked the 0 out of the domain. The domain for our g of x, right, this x minus 1, well, this is a polynomial. And we've talked about a couple times that polynomials exist everywhere. So we don't have any division by 0. We don't have any square roots of negative numbers. So this thing is going to be just fine everywhere. So our domain for g is going to be the entire real line, -infinity to infinity. Our composition function, f of g, right, f of g of x, means that everywhere where there was an x, we now have a g of x. So that's going to be 2 over the absolute value over g of x. G of x is this x minus 1. So it's going to be 2 over the absolute value of x minus 1. Okay. So again, we're looking into the domain. And the domain, well, we haven't added any roots. Okay, so we don't have those to worry about. We do have this x absolute value of x minus 1 that's sitting on the bottom here. Okay, remember, x minus 1 will shift our absolute value of x 1 to the right. So this absolute value of x minus 1 is equal to 0 wherever this thing touches the x-axis. Since we've moved it to the right, this now happens at x equals 1. So x equals 1 is now our problem point. So our domain is everything except x equals 1, or in terms of our set notation, -infinity to 1, union with 1 to infinity, and remember we need the curvy braces on the 1 because we plucked that point out of our domain. Now if we want to double check this with a graph, let's see what those look like. So looking at the graph, we have this, our 2 over the absolute value of x is in blue. It has this blow up at 0 like we expected. Our x minus 1, our linear, is nice and behaved everywhere because it's polynomial. And our composition function, 2 over the absolute value of x minus 1, well, it looks like it's just taken that asymptote that we had at 0 and shifted it over here to 1. Okay, so it looks like we are in good shape there. So this thing doesn't exist at 1, so that's not in the domain. It seems to exist everywhere else just fine.